gonna run through the answers real quick on the homework, if that's okay. Alright, so problem number one. Problem number one looks like I add 24 to both sides, then divide by 6, so I find that x equals 6 on the first one. Problem number two breaks up into the difference of two squares to break up to x plus 4 and x minus 4, so the answers are negative 4 and positive 4. Problem number three looks like we'll have to move the 50 over. So we'll get m squared minus 15m plus 50. So that would be, let's see, m minus 5, m minus 10. So m equals 5 and m equals 10 on number 3. Number 4, it looks like we have a greatest common factor of 3x we can factor out. So one of our answers is going to be 0. And then our other answers will be positive 3 and negative 3. Problem number 5 looks like we need to move the 3 over, so we have 2a squared minus a minus 3. Someone have an answer on that one? Can't do it in my head. You get it, TJ? You always think they got number 5? What do you got, Matt? Ray, did you get number 5? I can't do it in my head. Some big number? Hear that? What is the probability that's the only one you didn't do? 50-50, right? I gotta work it out real quick. Okay. So 2a squared minus a, and I'm moving the 3 over so I get this. Is that okay? Yeah. So we're solving it because it's an equal sign, so that's a negative 6. So I need to know my factors of this. So 1 and 6, 2 and 3. And so it's going to be 2a squared minus 3a plus 2a minus 3. GCF here is a, so I get 2a minus 3. And I'll factor a 1 out of there. Plus 1, 2a minus 3. So I get a plus 1 equals 0 and 2a minus 3 equals 0. There's those two answers. Just couldn't do it in my head, I'm sorry. Kind of curious, why am I going over this and there's like 5 people that actually have it out and the rest of you are sitting there with nothing out? Unbelievable. Do you not know how to play school yet? Number 6. So that'll factor down to, just doing a quick, minus 9 plus 6. So x equals 9, x equals negative 6. Number 7. Looks like GCF of 2 can factor out. This will factor to x. We just ignore that now when I'm solving it. So that'll be x plus 6, x minus 5. So x equals negative 6, x equals 5. Number 8, looks like there'll be one solution, so I get 12, x equals 2 on number 8. Number 9 will be answers of negative 5 and negative 6. Number 10, I can factor out a 2 from everything, so that would be 20x plus 100 equals 0. And then, so I already factored a 2 out. So x plus 10, x plus 10. So the answer to this is x equals negative 10 and you could write it twice. It's called a double root. This has a parabola when graphed would bounce off the x-axis. Number 11. I'm going to move everything over. And then my magic number looks like it's going to be 24. They both have to be negative because that's negative there. So 1 and 24, 2 and 12, 3 and 8, 4 and 6. Both being negative, 3 and 8 will work. Nice catch. X there, so 2x minus 3. There, I can factor out a negative 4. Minus 4, 0, and 2x minus 3, 0. And x equals 3 over 2. Number 12, the answers are positive 5 and negative 5. Number 13. Can't do it in my head. Distribute the negative over. All right. You gonna make it?
Yeah.
Do you need a sip of water or anything?
Yeah.
Go ahead.
No. You stole my water.
Subtract x. Subtract 8. So x is equal to negative 2. Number 13, let's see. If I add 24 to both sides, let's see, what is that going to be? That's negative 36. $14 will not factor down. It won't factor. So it would be a prime problem for right now. Number 15. This is one of those trinomials, so I can factor out an x from everything. So one of my answers is going to be x equals 0. That takes care of that. Factor this out. So two numbers are multiplied to give me 100. Add to give me negative 21. So factors of negative 100. Hey, you are all fancy dressed today.
I'm trying. I figure if I'm handing out bad news, less people are less likely to
Not
yell
bad
at me.
news.
So this is what we talked about too.
Yeah.
6, and then here's what I have: the 0.1 is medical careers, and 0.3 is J. So I'm hoping that that's the case.
Yeah, that's the case.
Okay, so we're good.
Is this mine now?
That is yours.
Thank you.
Have and hold, and that's upstairs. It's likely I'll move your office up there then too.
Okay.
So you're moving on up.
Moving up in the world.
Moving on up.
I'll take the desk with the.
The view of the Pikes Peak belongs to me.
It does not take.
Yeah, I'm sure it is.
Yeah. Cool. Where was I on this one? Okay. Factors of 100, 1 and 100, 2 and 50, 4 and 25. 4 and 25 are going to work. Both. So x equals 25, x equals negative 4.
Yeah.
Hey, why does this one have 3 answers? Shh. Do what? Solve for 0, yes, but why is there 3 answers? X to the third, good. And I think we're good for the rest. Cool? All right, let's move on. So notes for today. This is going to go over 2 days. And remember we said next week's going to be a goofy schedule, right?
Yeah.
I think we have this class Monday, Wednesday, Friday. I think if I looked at the schedule right, but I might not have. Yeah, it's later though.
Yeah, it's like.
Yeah. So Monday, Wednesday, Friday. I think that's what they said.
Yeah, Friday's a normal day.
A normal day, right? So, things for you all to know. If of these state assessment tests for you guys to take, you on some of them, on one of the math ones, I believe it is, you're allowed to use a calculator on. It might be two of them, I think. The nice thing is, if you use your own calculator, you understand your own calculator, which is good. But the bad thing is, to keep things correct, the teacher, if you pull out a calculator to use, if it's just a regular 4 function, there's no big deal. But if it's like one of the bigger calculators, the teacher has been instructed to clear any of the memory out. So there is a place on those TI calculators you can store notes, and so that'll be cleared out. So it'll be a reset of the memory. So just giving you a heads up on that.
I know you can play games, but not.
Yeah, the games won't be affected by any of the clearing. Maybe your high score will, but that's about it. So for you Star Wars fanatics, I just saw this morning the teaser trailer for episode Rogue One is out December. You gotta watch that now.
Like Star Wars.
Star Wars. So Rogue One will take place when you watch the trailer. I think it's between episodes 3 and 4. It shows how the Death Star plans were stolen and how the rebellion started. So.
Wait, so is it based on
Why are they
the
going
game?
out of order now?
Is it what
Is
based on?
it based on like the?
I know they've been
No, this is
It's
kind of like
it's a different.
it's backfilling, like
Oh, okay.
getting other stories.
So you're gonna have like.
Yeah, I think it's gonna be crazy. What do you got, Angelo?
So I heard a story.
You heard.
Yeah,
In the crowd.
The Death Star is really a triangle.
I'm sorry.
Dude.
Yeah.
That's what I heard.
And then the other episode.
Because my friend is very smart. He said that remember the guy in the laundry
No.
yes. Oh, who is that?
Oh yeah, baby.
That big guy from this.
There's all kinds of good old rumors on that. I've been following that stuff. Let me see what I got. All right. Here we go. All right, this is factoring special cases. There are special case things to factor. The one that we've seen quite a bit of is the difference of two squares. Okay, meaning you have two perfect squares that are separated by subtraction sign. So that your one that you kind of have as a back pocket, and you can write this down as notes, is the difference of two squares. And so things you've seen as far as this goes, you've seen things like this, and this would be if you were to factor it. Or you might even see something like this. And that's sometimes a trickier one because people don't realize that 4x squared is actually a perfect square. It's actually 2x and 2x and 49. So this one would break down to 2x plus 7 and 2x minus 7. So difference of two squares is your first of your special cases that take place. The nice thing about when you deal with difference of two squares, if you're graphing it, your vertex will always fall on the y-axis because your b value, a lot of times the difference, or most of the time the difference of two squares is 0. It falls out. Okay? And this should go down to, I think you have these problems. So let's see, find each product. So let's practice this. Let's make sure we can do this right. So if I multiply this and this together, what do I get? 16x squared, thank you. And then if I multiply the outside, I get what? No, at the outside. So plus 36x. You're right, you just want to step ahead of me. And then the inside, what am I going to get there? Negative 36x. And then if I multiply the last one, I get negative 81. So these cancel out because they're opposite values. So then I get 16x squared minus 81x. Okay? So that's what the difference of two squares looks like. Problem number 2. Walk me through it. Okay, x squared, and then x times 2, I like it. And then what? Okay, good, good. So these cancel each other out, leaving you this. And again, that's the difference of two squares. Now, number 3 is a little different. How many x minus 8s am I multiplying together? 2. So if you write this to look like this, you get there. Is that okay so far? Yeah. And now let's multiply it out. Do these cancel out? No, they're not opposite signs. So this one is called a perfect square trinomial. Okay? Is there really a trick to doing it? I mean, you could say, well, this will be squared, and then I'll double this, and that's how it works. But I don't know if it's always the right way to go with that. I would say just multiply it out completely and you should be fine. Number 4. The order of operations would suggest to take care of the exponent first. So how many x plus 1s are we multiplying together? 2. So you get negative 3, x plus 1 times x plus 1 minus 6. Is that okay so far? Does everyone see where the x plus 1, where the squared went? Okay. So we're just going to multiply this out first. So I get negative 3, x squared plus 1x plus 1x plus 1 minus 6. Let's combine like terms inside. Is that okay so far? What's the step next? Distribute where? Good. Distribute the negative 3 over the parentheses. And then we have that minus 6, so we'll combine that into it as well. So combining like terms. And this is done. My allergies are starting to kick up a little bit. I don't know about y'all. Man, things are blooming. No?
Probably because I'm more usually late out of bed.
Yeah. Well, I'm glad you're not late out of bed this time. All right. All right, so difference of two squares. Again, the tough thing on difference of two squares is sometimes it's hard to identify that you have perfect squares. Most times, okay. Most of the times, if you're on a factoring adventure, take a look at it. If you happen to have two terms that are separated by a subtraction sign, ask the question, is this a difference of two squares? Is my first problem a perfect square? Is my second one a perfect square? I don't think he wants to play spank and tickle.
Oh, snap.
Alright.
Stapling pencil.
Oh yeah, I might be able to bust chops on some people sometimes, right? Factor completely. Factor completely. I like it. Can I factor the first one?
No.
It doesn't break down to x plus 1, x plus 1?
No.
No. I don't think that one can be factored. Okay? So, for right now, we're just going to call it prime. For right now, we're just going to call it prime. But we will eventually get to a part where we will be able to use the quadratic formula on this and then break it down to find the answers. So that first one's prime. It's not going to work out. Number 6.
Yeah,
It'll factor. What does it factor to?
X plus 8, X minus 8.
There you go. X plus 8, X minus 8. Difference of two squares. You guys okay with that? Two terms separated by a subtraction sign. They both happen to be, the terms happen to be perfect squares. X squared is a perfect square because x times x is equal to that. 64 is a perfect square because 8 times 8 is 64. Number 7, does it factor?
X plus 5, X minus 5.
X plus 5, X minus 5. It is the difference of two squares again. Again, you look at it, you say I have two terms separated by a subtraction sign. Are the two terms perfect squares? In this case, it again is yes. Number 8, x squared plus 20x plus 100. Does it factor?
No.
The factors of 100 are 1 and 100, 2 and 50, 4 and 25, 5 and 20, 10 and 10. Any of those factors add up to be 20? 10 and 10. What does this factor to?
X squared plus 10x plus 10x.
What do you think? Does that work? X times x, x squared, plus 10x plus 10x. That's 20x. Plus 10 times 10, which is 100. How can I write this as an exponent? How can I write it as an exponent? How many x plus 10s do I have? 2. So both answers are fine. Your choice how to write it. Just realize how one breaks down to the other. Almost done? 5 problems left. Yeah, buddy. 5 problems left, and then there's one box problem that we're going to work on a little bit too. But we'll get there. All right. Number 9. 25x squared minus 9. I have two terms. They are separated by a subtraction sign. Is 25x squared a perfect square?
5x, 9,
Uh-huh.
and 5x. Oh no, 5x plus 3, 5x minus
Good job, Matt. 5x plus 3 and 5x minus 3. Again, 25x squared is a perfect square because 5x times 5x. 9 is a perfect square because 3 times 3, they are separated by a subtraction sign. Question? No? Question?
Yeah, why is it 3?
Because what's the square root of 9?
Gotcha.
So if I were to multiply it out, I'd have positive 3 times negative 3, which is negative 9. Number 10. It might factor out. I don't know. It might be a perfect square trinomial. I think this would be the answer. I think that might be the answer. What do you think?
Where's the 12x?
Oh, hang on. Let's see. Okay, let's see if we work this out. Ready? Shh. If I multiply those together, I get 4x squared. We agree. Yes? And then I multiply that and I get negative 6x, negative 6x. Negative 6x and negative 6x is negative 12x. And then negative 3 times negative 3 is positive 9. So if you don't see this way, do it our other way. Saying, okay, well I have 36 and the factors of 36 are these. And the two that have to be, both have to be negative in order to get there. So if you use that in our traditional way of factoring, it'll work out. This could also be written like this. So this could come in two different forms. Either answer is fine. Number 11, two terms separated by subtraction. Is the first term a perfect square?
Yeah.
Yes?
Negative
Yes,
2x
it is.
plus 11 negative 9.
I like the way you're trying to go with that, Mac, but I would go this. You were trying. You wanted the x to come first. I get it, but it's okay to do that way. So that's the difference. Two squares where the x isn't coming first. That's okay. Number 12. 25 plus 10x plus x. First off, could this be written this to look like this then? My first term's a perfect square. My last term's a perfect square. It is very possible this will be x plus 5, x plus 5. Well, let's see if that actually does work. Okay? X times x, x squared. Plus 5x plus 5x is 10x. 5 times 5 is 25. Cool. Yeah, it does work. So another way to write this would be what? X plus 5 quantity squared. Good. And then x squared plus 64. X squared plus 64. It's two terms, but it's not separated by a subtraction sign, is it? No? Let's see. Could this be x plus 8 and x plus 8? Sum of two squares doesn't exist. So if I were to take x plus 8 and x plus 8, which a lot of people might go to, I would actually wind up, if I multiply it back out, with x squared plus 16x plus 64, which doesn't work. So this is another one that happens to be prime or does not factor or something like that. We all right so far? All right, here comes the bonus one. Find the shaded area, factor if possible. So I think the shaded area we're looking for is the grayish bluish area. So this is two different squares. So if this side here is x, what would you call this side here? It's a square. Square has the same length and width. Okay? So if this length here is 4, what does this length here have to be? 4. Okay? So if I have the area of the gray square, how would I find the area of the gray square? Area is what times what? Length times height or base times width or something like that. So length, width are both x. So the big square is x times x. What's x times x? X squared, okay? And the little square is what? How big? What's the area of the little square? 4 times 4, which is 16. So if I wanted to find the area of the blue, what would I have to do with the area of the yellowish? Times it by 4. Divided by 17. You're close. What should I do if I wanted just the blue area? Or that grayish area? What should I do with the two areas? Subtract the smaller one from the bigger one. Okay? So that means that I'm going to get x squared minus 16 is the area of the blue or the gray or whatever color that is. I don't know. Okay? Hey, what do you know about that? They can factor x plus 4, x minus 4.
Oh my God.
So you can leave it either way. So, what do you think? We there? Some of you guys are getting a little squirrely on me. Why? What happened? Springtime?
Oh, you want to know?
What's going on, T?
Never mind. I'll let it go.
What have we got to do?
I hear you. He just
I tried to escape as possible.
Who's trying to do that? It's whatever.
That's the whole squirrely thing?
Yeah.
You do freak out.
Teenage boys trying to steal each other. It's just fine now.
Ben, if you're gonna play in class, it's better to play with yourself at home. No, wait. That's still recording. Sorry about that. If you want to goof around, just keep it to yourself. Don't.
Good.
I don't want to leave the room at any time.
Oh shit! All right, guys and girls. Sorry about the silly slip. All right, so a few things. Schoology. I have quiz 8 and the mid-semester review. They will close on Saturday. Okay? So, after I open them up, a few of you that had done it, two of the few have done it. So go in and do it, please. There's another one on Schoology that is now quiz 9. Okay, and that is open until Saturday of next week. So it's good. This one's only worth 10. So, because Saturday next week. So, go ahead and realize you have those to work on. Tonight's assignment is going to be today's homework is going to be page 95, 96. And I would like you to do the odds only. So if anyone needs a picture of it, it's right here. It'll be up in the basket. Take the opportunity to start working on it now. Saving the video.